This is not a guide for using a hydrostatic cutter. Using a hydrostatic cutter is potentially dangerous and should only be done by qualified personnel operating in conformity with all applicable federal, state, and local laws and regulations.
All right, this here is the hydrostatic release. And the cool thing with the hydrostatic release is it's a way that you can sometimes cut the wire at the seabed rather than at the back deck. There's a couple reasons you might want to do that. If you cut the wire at the seabed, you still have wire on your drum and you haven't dumped wire into the ocean, so that's good. But that will potentially preserve your cruise if you're out for 40 days. You still have thousands of meters of wire left on the drum. If you're in 5,000 meters of depth and you cut the wire at the deck, then you've just lost 5,000 meters on the cable. You might only have 3,000 or 4,000 meters left and not be able to get to the bottom again. So this is a very handy device, and it was put together by Chris Greiner and Josh Eaton. Here's a little weak link we're going to talk about just briefly, but it's kind of related to what we're going on here. The device has some shear pins and a little shear pin scale, and then super heavy solid stainless thing looks like this. And there's a little tag here that says remove before splash, or your tag might say remove before flight. And so we're going to go through all of this and this little chart, and we're going to tell you how it works. The remove before splash is just a little bolt so that it doesn't come apart during shipping. And then you see there's these two holes here. So this is a little bit related to your weak link, which hopefully you've watched the other video of how the weak link works. This weak link is just what you're pulling on the dredge with, and depending on the strength of this bolt depends when it'll break and shear and pull apart. So this one's a silicon bronze bolt. It breaks at 4,500 pounds, 4,700 pounds. This bolt's an aluminum bolt, breaks at a couple thousand pounds. So you can see that you can gauge different amounts of pull on here with the strength of the bolt. In this device, these pins here that you set in, they're these brass pins. You can have a solid brass pin, which has no metal removed, or you can have a hollow brass pin, which has some metal removed. You can look over at the chart here. Depending on how much metal your pin has, the hydrodynamic force on this will guillotine the wire at a different depth. We don't expect that you would be this granular in the amount of metal you'd move with the different size hole that you would drill. But there's a lot of different values here depending on what size drills you have. The easiest way to drill this is probably on a lathe, so you maybe need some help from the engineering room. But never mind, I mean, if you're at full ocean depth, you're going to be using the solid pin, and it goes in like that. So the remove before flight bolt, pop that bolt out. Now this thing, you set it, put your shear pin in there. Yep, it's not going in. You can see that this one's kind of rusty, so we're going to later in this movie take it all apart and show you. And if you're not going in just like this, that's another reason why you might need to take it apart, because there's a plunger in here and a piston in here which slides through. If those have wiggled a little bit because this was removed before splash, then these pins aren't going to line up. So that might be another reason why you'd have to take this apart. So we'll just get into that, but I'll go through a little bit more of how this works. This little slot is what you put around the cable. These are the long bolts. You remove these long bolts, put it around the cable, put the long bolts back in, then it's ready to splash. And I'll take that off so you can see now. It sometimes doesn't actually cut the wire. Sometimes it only damages the wire enough, and then you would pull on it, and then that'll cut the wire. This is the reason they call them long bolts, because they're long, whereas this bolt is short, and there's some other bolts in here that are shorter. And then this is what the cutter edge looks like, which is inside here, and it goes up into this little slot and guillotines the wire. And it guillotines the wire on hydrostatic pressure. If you're at full ocean depth, you might have 6,000 psi on this plunger right here. That 6,000 psi is going to shear these brass pins that are in this hole and guillotine the wire. So that's kind of the idea how this works. that pops off. This part is heavy. You can see the little slot here. The little knife edge slides into that slot and guillotines the wire. So set that aside. But as you notice, we were having trouble getting these in. That's where you have to come in and sort of do a little bit of maintenance on it. The knife, this is a spare knife edge. The real attached knife edge is down in there already, but you see it comes through this little slot. So we're just going to go right into it and take it apart. These are just little pins, alignment pins, and then the other bolts come through the other holes here. There's the little alignment pin. There's the cutter in there. There's your little alignment pin coming out. And this is where this circle here inside of this is the cylinder, and that's the piston. And then there's a little stub that comes out that has the holes that have to line up for the brass pins that's attached to your cutter edge. So these pins that you insert in here, depending on which one you want to use, solid or hollow, will determine the shear force required at which they break. And then this knife edge here comes out and guillotines the wire. Comes right through the little blade guide. And what's actually doing it is there's a little air pocket in here we're going to show you in just a second. And this air pocket gets squeezed by the pressure at depth, just like when you send a styrofoam head down on a CTD and it comes up and it's all squozen, which is kind of a fun comic relief sort of thing in the middle of a long cruise. This is a great little benefit and use of that ocean pressure if you need to cut the wire. So we're just going to show you that little air pocket just so you can see what's going on. So this little cylinder, piston, here's the guillotine attached, here's the air pocket. There's a little rubber O-ring here, a little O-ring sleeve seal, and a little sleeve seal there. And if it's all rusted like this, the seals might not make good contact, and you might lose your pressure, or it might just be bound up. The other thing to know, if you do take this apart to hone it or anything, there's only one hole here, that's the remove before flight hole, and then there's two holes there. And those are the holes where you sit your brass pin to regulate the depth at which you want to send it down at. So it's a pretty simple, benign thing. Now you got this little air seal trapped in there. That guillotine is going to take out the wire. And if it doesn't cut the wire all the way through, maybe it'll damage the wire enough that when you pick up on it, the wire will break off. And all that happens out in the seabed, rather than right here on deck. So now we're going to show you how you reassemble it and then take it back out on deck and put it on the wire. This part, putting it all back together, is important that you get these bolt holes lined up or the knife edge won't come through that. You shouldn't ever have to take this apart. It should be sitting there in your little case somewhere in a nice dry storage, hopefully deep into the ship in a controlled environment, not out on the back deck where it's going to turn all rusty. But you want to look through and see if the holes are lining up, and that way you can put the pins through. You don't want to have the hole that lines up here be this face and these holes that line up here be over here, then you can't get into it. So that's about the only thing to check on when you're putting it back together. You can send a little drift pin through there or a screwdriver to line them all up. And this one's looking pretty good. The piston has to go in just a tiny bit more. There she is. And these are the bolts that you're going to take apart when you go out on the back deck to put it on. Pull this off, slide the cable through, put that back on, put it back together. So somebody is going to be there to help you with all of that. And then at that point, then you're ready for splash. All right, now we're going to talk about the hydrostatic cutter. If your weak link is not, has not popped, but you're rocked down and you're pulling super high tensions, 18,000 pounds, 19, 20,000 pounds, if you don't have an APA waiver and you're at 16,000 pounds, if it's been determined that you're going to try to cut the wire with the hydrostatic wire, you have to get control of the wire because you're not in the harbor, you're out at sea. And usually it's more intense if it's rough out. So you're going to come out here and lock off the wire just to make it easy. We're just going to put these on here and then tighten them up so the wire, you don't have to fight it. It's kind of like putting the pinger on the wire. And then, so we've tightened up on that, and that allows you to get this thing on there, which is kind of heavy. And then once it's okay with the bridge, everything's good, then we're going to go and actually drop it. We've been through all this. We're going to take this part off and put the hydro cable through there, the trawl wire. We've got one brass pin in there. We've removed before splash. That goes away. Here's our brass pin again. We're only using one solid brass pin because we want to make sure this has enough hydrostatic pressure to cut it. This little piston in here, we've rebuilt this thing. We know that's going to move. So we're going to go out there, take this off here, and get someone to help you out because these are heavy. And even though we got the wire under control, it's still going to be moving a little bit. There we go. You hold that. I'll give you that. Here's our little cutter. Boop-a-doop-a-doo. You can try to pull the pins all the way out.
Okay.
And then we only have one to hook in, or pull out one pin. Actually that, well, I don't know. That one might be easier. So, and then turn your guy, there you go. Is it tight? Ah, yeah. Two people to hold the two independent pieces of heavy metal and a third person to operate the wrench. Now I can rest my hand on these things. That's why these are on the bottom at first. There we go. All right. The hole with the remove before splash, that bolt is gone. We've got one solid brass pin in there. And now we're ready to drop it. All right, so we've got permission from the bridge. We're all good. We're going to slack these and get ready to drop it. So go ahead and slack. All right, now at this point, you're waiting for the bridge's call. You talk to them on the radio. And when they give you the call, then you dump it over the side. It's getting heavy. Okay, bridge, we're doing it as of now. Mark. Ooh, yeah, baby. Keep your hand on this, maybe, and you can feel it going away, and then walk back off the deck. We're good.